Assalamualaikum and hi to everyone. Thank you for watching this video. This video will continue on the second chapters of operating system. So we will talk and discuss about the system call. So if you still can remember, in the previous video I show you a diagram that we have the hardware. Inside the hardware we have this OS, the operating system. So inside the operating system we have the services that provided by the operating system, and then we have the user interface, and between the user interface and the services we have the system call. So today in this video we will discuss about the system call. Okay, programming interface to the services provided by the OS. So that is referred to the system call, and typically written in the high-level language, high-level programming language, which is usually using the C or C++. Okay, mostly accessed by the program via the high-level application programming interface that known as the API, rather than the direct system call use. So basically, we will access it through the API. And the three most common APIs for the operating system, okay, we have Win32 API for the Windows operating system, and then we have the POSIX API for the POSIX base system. So this POSIX API including the virtually all version of the Unix and Linux as well as the Mac operating system X. Okay, and also Java API for the Java virtual machines. So basically the API are differ based on what kind of operating system that do you use. And in the discussion for the whole semester about the system call, we go for the generic part or for the general things regarding the system call, and not specified to the certain operating system. Just get the overview and get the what we call as knowledge regarding the system call in the overview or general part. Okay, this example of the system call. Okay, we have the source file and we have the destination file, and what we want to do is copy the content of one file to another file. Okay, when you use your computer and you do the process of copy and paste, it looks like easy and simple, right? In just a few seconds, you're able to copy from one file to another file. However, there are sequence that you need to know as a computer student. Okay, so let's say example here, system call sequence to copy the content from one file to another file. So you look at this diagram. So we have the source file and we have the destination file. So the task is copy from the source to the destination. Okay, these are the example of the system call sequence. So first, what are the sequence? Acquire input file name, then write prompt to the screen, accept the input, acquire output file name, and then write prompt to the screen, accept input, open the input file. If the file doesn't exist, abort the process, create the output file. If the file already exists in your computer, then abort the process, and then do the looping process. Read from the input file, write to the output file until read fails, and then close the output file, write completion message to the screen, terminate normally. That are the sequence. Okay, that are the sequence in order to copy the content of one file to another file using the system calls. Means there are sequence that we need to follow one by one. There are steps that we need to follow one by one in order to copy the content from one file to another file. So this is the example of system call sequence. Okay, now we look for the example of standard API. Okay, so in the standard API, we can use the function read. Here we try to read from the API application. So we have read function, and the function of this read function, okay, is used to obtain from the main page by invoke the command, okay, the API command. Main read here, main page. Okay, so basically it's available in the Unix and Linux system. Okay, on the command line, okay, a description of the API appear like this one. So we need to we need to include the library unix standard.h. Okay, and then under this part, under the read function, okay, we have the return value data type here, and then we have the function name, which is read, and then we have the parameters. Okay, parameters inside the read function. You recall back the knowledge that you learn about the C or C++ programming in here. Okay, so a program that use the read function must include the unix standard. Okay, this one is the library for the header at the header part, as this file define the as size t, okay, based on this one, the parameters and amongst things. So the parameters pass it to the read function as follow. So integer, this one is data type for the file descriptor to be read. Void here buffer, a buffer into which the data will be read, and then size t here, size t count here, the maximum numbers of bytes to be read into the buffer. So on a successful read function, based on the read function, number of bytes read is written, and a return value of 0 indicate end of the file, and if an error occurs, read function will return the value of -1. So this is how the system call use this API for read the file. Okay, the next part we go for the system call implementation. So a number is associated with each system calls. Basically we have the number that associated with each of the system call. Okay. And the system call interface maintain a table index. Because we use a number, so we have a table index according to these numbers. And the system call interface invoke the intended system call in the operating system kernel and return the status of the system call and any return values. If error is negative, if done, complete 0. Okay, and then the caller need to know nothing about how the system call is implemented. This part is based on the caller. Okay, and just need to obey the API we use. Depends on type of Windows, type of operating system, and understand what the operating system will do as the result call. And most detail of the operating system interface is hidden from the programmer by the API. So we just call the API without without knowing what happened behind that. Okay, so this part managed by the runtime support library, which refer to the set of function that built into the library included with the compiler. So we just use the library. How it's work? We have the API, and then we have the system call, and then we have the OS. So using the operating system, we have two type of mode, user mode and kernel mode. And then this system call interface will interact with the user or program or application. So it will open this. Okay, let's say this is Telegram. So we open the Telegram. The system call it. So it need open. So what happen here? Okay, call the function open and then implementation of the open system call and then return the values here. Okay, return the values here. And then this one is referred to the index table that I've mentioned in the previous slide. Maintain table index according to the number. Okay. And then the next part is about the parameter passing. So more information is required than simply identity of the desired system call. The exact type and amount of information vary according to the OS and the system call. The three general methods used to pass the parameters to the OS. Okay, we have the simplest. Pass the parameters in the registers. Okay, register is one type of memory in our computer system. In some cases, maybe more parameters than the registers. That part is the simplest. Then parameters stored in a block or table in the memory, and address of block passed as a parameter in a register. Okay, this one is simplest part. Pass to the parameter in register. This one parameter stored in a block or table in the memory, and the address of the block will be passed to the parameter in the registers. So this approach taken by the Linux and Solaris. So if we use the operating system, the Linux or Solaris, so that use this kind of method. The next method, parameters place or push onto the stack by the program and pop off the stack by the operating system. This one is the third method. Okay, on how it pass the parameters to the operating system. And the fourth part, block and stack method do not limit the number of length of the parameters being passed. So these are the general method. Okay, general method to use in order the general method that we use in order to pass the parameters to the OS. Different operating system use different method, but we talk about the general process. What happened in generally. Okay. Okay, this diagram will show you the parameter passing via the table. So we have the operating system, we have the user program, we have the register. So user program, this program X, this program E, okay, X parameters for call. So load address X, system call 13. So it's load the address X to the register. And system call 13, okay, address X, system call 13. Okay, and then at here, use parameter from table X. So code for system call 13 known based on this part. Okay, and then this one is the operating system. So the parameters X is passed via the table. Okay, next we go for the type of system call. Okay, system call can be grouped roughly into 6 major categories. Okay, we have the process control, the file management, the device management, information maintenance, communication, and protection. Okay, it's quite similar like the previous in chapter 1 that we have discussed about the resource management, about the management. Okay, we have the process management, we have the file management, and so on. So based on that services that provided by the OS. Okay, the first type of system call is the process control. So it create the process, it terminate the process. Okay, and abort, load, execute. Get the process attribute, set the process attribute, and then it has the waiting time. Wait for the event, signal event, allocate a free memory, dump memory if error, and then do the debugging process, bug, single step execution, logs for managing access to share between processes. So it's more on how to control the process inside the operating system. Okay, second part is about the file management. So it's used for create a file, delete the file, open, close, read, write, reposition the file, and get set file attributes. Okay. Number third is about the device management. So using the system call, type of system call for device management, you can make a request of device that we have at your computer. You can go to my computer and then you can do the management part, and then you can look at the device part. Okay, and then request, release the device, do the read, write, the position of the device, get the attribute of the device, set, enable, disable of device. Okay, and logically attach or detach the device from computer system. Okay, number 4, we have the information maintenance. It is more on the maintenance, more on scheduling part. Get time or date, set time or date when you want to update. For example, okay, get the system data, get system data, set the system data, get and set the process, file and device attribute. Okay, that's why you can do the scheduling when you do programming. That's why you can get the current time, current date, today's date, okay, based on whatever your OS able to provide to you. Okay, and then number 5, about the communication. You can create, you can delete the connection. Okay, create and delete communication between you and the others. You can send, you can receive message, you can pass your message, you can receive the message through the computer system. Okay, for example, we have the client and server. You can share the memory model, operate, gain access to the memory regions. You can transfer status information, okay, attach, detach, remote devices. Okay, that part for the communication. And for the protection, okay, we can control access to the resources that we have in the computer system. We can get and set the permission for resources that we have, and we can allow or deny the user access. It's one for the protection. And then next, in this slide, it show you the example of the Windows and the Unix system call. Okay, the previous one, we look for the copy content from one file to another file. So in this example, it shows or it illustrates you the various equivalent system call for Windows and Unix operating system. Okay, for the process control in Windows, we have create process, exit process, wait for single object. Using Unix, we have for exit, wait. Okay, this one is more simple compared to this function. Okay, for file management, we have create file, read file, write file, close handle, open, read, write, close. Very simple. Very simple and understanding. Okay, and then we have device. For device management, we have set console mode, read console mode, write console. And then here, okay, read, write. The next part, we have the information maintenance. Get current process ID, set timer, sleep, get PID, alarm, sleep. And then for the communication, create pipe, create file mapping, map view of file. Okay, this one quite similar. like map, and then open the mapping file. And for protection, we have set file security. These are the function in the operating system. Initialize a security descriptor, chmod, umas, ch1. Okay, this one security description group. So these are the example of the function in the system call for the Windows and for the Unix operating system. And next is about the standard C library example. Another example based on the C library. So C program invoking printf library call, which called write in the bracket. This one is the write function system call. So the standard C library provide a portion of the system call interface for many version of Unix and Linux. So example here, let's assume the C program invoke the printf statement, function printf statement. So the C library intercept this call and invoke the necessary system call or call in the operating system. So in this instance, for this example, the write function system call, the C library takes the value and return by the write function and pass it back to the user program. So it header, it include the stdio.h, and then this one is the main program, integer main, and then it invoke the program using the printf greetings in the string data type, and then it will return the 0 close the program. So we have two mode in the operating system, kernel mode and user mode. Okay, this one is standard library for the system call. Okay, write function. So write function system call to the standard library. Okay, based on this command that you write in your C programming. Okay, it invokes pipe to write because you want to print the greeting, so it invoke to write. So it will write to the system call, and system call give the output the C library. Okay, and here the C library take the value returned by the write function and pass it back to the user program. So it return and then it will pass to the user program. Okay, this one is the application that written by the user. So how it's work. Okay, another example here is based on the Arduino. Arduino also use the C language. So we have A and B. At this part, system startup. At this one is running a program. So we have the bootloader and free memory. So when you run the program, you have the user program and the free memory, because this memory is being used by this user program. So Arduino is single tasking. Arduino is a microcontroller. It's not like the Raspberry Pi. Raspberry Pi, it has the operating system its own, but Arduino, it does not have the operating system, but it has the memory. So programs cache load via the USB flash. Okay, you can use the USB cable in order to load your program when you do the coding using the cache. Okay, you do the coding, and then when you want to load your program to your Arduino board, you can use the USB cable into the flash memory at the Arduino board. Okay, and then single memory space, and bootloader load a program, and program exit shell reloaded. Okay, you can click on this link in order to see the Arduino temperature sensor. But basically, when you use the Arduino microcontroller board, you have the IDE. You need to have the Arduino IDE in order to do the programming part. And then after that, after you're done with the programming part, you need to flash, or you need to load the program to the microcontroller, to the Arduino board, and then it will save your program in its memory. So it only has single memory. So let's say you have the Arduino controller is only can work with one program at one time. Okay, so maybe later on you can learn about the Internet of Things. Sorry, you are computer science student. Okay, sorry. Okay, about you can learn more about Arduino board later on, in order to know the difference between Arduino board. But Arduino board doesn't have the operating system. Maybe we should discuss about the Raspberry Pi, because Raspberry Pi has the operating system. Okay, so these are the example, step and sequence by Cont. Okay, this one is another example of FreeBSD. Okay, this one is unique variant, one of the Unix OS multitasking. So user login, it will invoke the user's choice of shell. Okay, this process part, it has kernel, free memory, process C, interpreter, process B, process D. Different. It is different when you compare with the Arduino. Okay, it's different. So shell execute fork system call to create process. Okay, you can look back at the previous slide about the forks. Okay, this one, Unix, right? Okay, Unix variant. So we use the fork function. The system call to create the process, and then execute exec function to load the program into the process, and then shell wait for process to terminate or continues with the user command based on what the commands sent. And the process exit with code 0 means no error, and code more than 0 means it has error. So it has the low memory, high memory. So at high memory, we have the kernel and the free memory space here. Process A, process B, process D, and then we have the interpreter. So that's the example of the different type of operating system, different type of board. Yeah, Arduino, this one is the standard part, but basically this is how the system call work. Okay, based on this process. On the system call, we have the process control, file management, device management, information maintenance, communication, and protections. So the next part, we will talk more about the system services. That's all for this video. Thank you and Assalamualaikum.